good news. Today's lesson is very easy and chill. It should not interfere with your work on chapter 5 at all. It is hopefully relatively quick. I'm hoping I can finish it in enough time to give you some time to work on your note card and study. So this is extremely easy. It's kind of stupid easy. To be honest, the first few sections of chapter 6 are like chapter 2 review. Yay! So it's extremely straightforward. Okay. 6.1a, discrete random variables. This is not a hard chapter. I promise you there are some new calculator things to learn, but other than that, it's not bad. Consider a spinner with 3 outcomes, 2, 4, and 5. The spinner has a 30% chance of spinning a 2, a 20% chance of spinning a 4, and a 50% chance of spinning a 5. Define the random variable x. Okay, so this is kind of new for us. We're assigning a variable to an event now. So we're taking the probability stuff from chapter 5 and we're saying, okay, now we're going to call it something. We're going to call it x. And that's going to be the outcome of what you get in the spin. Does it make sense to you that x in this case could be 2, 4, or 5? That's why it's a variable. Okay, so I'm going to take my spinner here and I'm going to lop off 50% because it says 50% chance of spinning a 5. So that's going to be 50% chance of spinning a 5. Does that make sense there? And then I'm going to say, okay, yeah, maybe here-ish. 30% chance of spinning a 2 and a 20% chance of spinning a 4. So I just split it into pieces. It's not really greatly divided, but it's fine. Everybody okay with my spinner setup? Okay, explain why x is discrete. X can only be 2, 4, and 5. There's no ability to get a 5.3 or 7 or a 6.7 or a 6.7 or 67. Just 2, 4, and 5 are your only options for spinning the spinner. That's why it's discrete. Does everybody remember what discrete means? Like gaps between? Okay. Create a valid probability model for x. This is great. Chapter 5 review. Okay, so we're going to put x here and the probability of x here. And I notice I have an extra line here. I'm hoping that you put an extra line here. And our 3 options are 2, 4, and 5 on the spinner. And on 2 is a 30% chance. And on 4 is a 20% chance. And on the 5 is a 50% chance. And what makes it valid is that those things are all between 0 and 1, and they add up to 1. So remember when I made you guys add the tree things up to 1? That's what made it valid. Do you guys have any questions about what we did so far? Isn't it wonderfully easy? So I split up the spinner, I explained why it's discrete, and I set up a probability model. Okay, now I'm going to let you set this up while I take attendance before the office calls angrily because I didn't do it. And they will. Oh, they will. And Mrs. Talbot might get an email that says something like, you must take attendance within the first 15 minutes of class. And that might be repeated emails that they send me indicating this, my failure to do so. I don't know, maybe this is just, some kind of fiction story. Or is not. I'll let you decide. Yeah, I don't look at that. Oh God, I froze it on that. Don't worry, there wasn't anything bad. Except for maybe emails about me failing to submit my attendance within 15 minutes of start of class. But it's 8:44 and I did it. So it's sorry, I won't get one this period. All bets are off second period. Yeah, I know. Nice. Should get a sticker. Okay. Create a probability distribution histogram for X and describe its shape. Okay, so we're gonna make a histogram. It's gonna be a weird histogram because it's gonna feel like a bar graph, but it's a histogram. I'm gonna put 3 options on the bottom, and those 3 options from my spinner are 2, 4, and 5. I know. Okay, and then it says probability distribution, which means that the numbers on the side need to be probabilities on the y-axis. And I'm saying that because I want to remind you that probabilities need to be between 0 and 1. So when you're doing that test tomorrow, you're not going to leave any questions with a negative probability or a probability over 1. 0's okay. 1's okay. Anything in between those two is okay. Anything else, not okay. Okay, so to spin a 2, well, let me, okay, to spin a 2 was a 30% chance. To spin a 4 was a 20% chance. And to spin a 5 was a 50% chance. Man, Mrs. Talbot, I don't know if I can handle the difficulty level of this lesson that you're teaching here. I mean, it's rough. We had to write numbers down and make bars the same height as that, and just can't do it. Just gonna throw my pencil. Okay, D. What value can you expect to spin over many, many trials? Calculate and interpret your results. This is great because we're going to practice writing long-term, long-run relative frequency statement, which is describing probability, which is from chapter 5. Look at me. Okay, so we're going to use a new vocab word though, which is expected value. And we use the symbols expected value of X here, or weighted average. What's the thing that you guys calculate all the time? Actually, you don't, but you let Aries calculate for you all the time that is a weighted average. GPA. Okay, so GPA is an example of weighted average, which means that each category has a different weight. Oh, look, here's categories with different weights. Oh man. Okay. Anyway, but right here I'm teaching you symbols. So expected value is this symbol. Weighted average is this symbol, which means mean of X. And those are the same thing. I'm going to use them interchangeably just to drive you nuts. No, I'm going to use them interchangeably because you should use them interchangeably. And if you see the mean, then you know that that's expected value. And if you see expected value, you know that that's the mean. It's just like saying f of X and Y, just completely interchangeable. And what do we do to get our GPA? We take, you look on Aries, you go to Clever, and then, no. What I mean is you take the weight of an A times how many A's, right? Take the weight of B. Okay, so we're going to do the same thing, but I like to use it from the table. So watch up here. It's the value times its weight plus the value times its weight plus the value times its weight. Okay, so what I'm going to do is say top times the bottom plus top times the bottom plus top times the bottom. Okay, so 2 times 0.3 plus 4 times 0.2 plus 5 times 0.5 is 3.9. Okay, students get really nervous about this because they look back up at the spinner and they're like, Mrs. Talbot, I can't spin a 3.9. You just told me it was discrete. 3.9 wasn't one of the numbers. Okay, but what does that mean? So think back to chapter 5. This is an average over many trials. Okay, so after many spins, that should be the word many. I don't know what happened there. After many spins, you would expect after many spins, you would expect to get about 3.9 on each spin on average. So this is like long run relative frequency, meaning over the long run, over many, many spins, it should come out to be 3.9. Do you remember when we did the coin tossing applet and it was like diddly 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 and it came around to the 0.5? This would go diddly 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 and come around about the 3.9. How would it do it again? Diddly diddly. Anything I can do to make it fun. Okay. All right. Anybody still writing? Okay. While you guys are setting this up, I'm gonna bring you note cards, indicate if you need one or do not need one. That's okay, just write everything. Right over it. I was afraid I was gonna forget. Okay. While you're writing, no, it's okay. I'm not writing anything yet. I want you to think about, try to get back into the recesses of your brain from chapter 1. I know. And remember how we calculated standard deviation by hand. So it was that video where I screwed it all up. Remember the video where I screwed it all up? Okay. Okay, but what was I doing? Well, other than I skipped a number, that was the main problem. I left a whole number out of the, I don't even know. Should just redo that number and not try to do 40. I don't even know how many numbers I was trying to, it doesn't matter. Doesn't matter. It was a low point. It's fine. We come back from that. We persevere. It's all good. But what was I doing? Like what math was I attempting poorly to do? What do you do when you do the standard deviation? What's the calculation? Oh, I heard stuff. Okay, I heard some intelligent things. The first thing you do is that you take each value and so you subtract the mean from it. So I listed all the numbers. I subtracted the mean and then I squared them. Then I added them all together. Then I divided by n minus one, the number of numbers minus one, and then I square rooted. It sounds so simple now. Okay. We're going to find the variance and standard deviation of a weighted set of numbers in this, but I have good news for you. The calculator will do it. So I'm going to show you how to do it by hand, and then we're going to do it on the calculator. Okay, so we're going to do x and the variance of x. And if you forgot what variance is, that's just what you get right before you square root. So it's standard deviation squared. It's like the number right before you square root. Okay, and I want to remind you guys that from our previous problem we did, the mean was 3.9. Do you remember that? Okay, so in this box, I'm going to say value minus the mean squared. In this box, I'm going to say value minus the mean squared. And in this box, I'm going to say value minus the mean squared. Oh, Mrs. Sabat, you only have 3 this time. You have a chance. And the weight on 2 was 0.3. The weight on 4 was 0.2. And the weight on 5 was 0.5. Yeah, it is. And we will not do it by hand very often. All of this white space down here is for me to teach you how to do it on the calculator. So again, top times the bottom plus top times the bottom plus top times the bottom. And just for speed purposes, I'm just going to give you the number that would be you would get from the calculator if you added all of that up. Okay. So again, the variance is just the number that you get right before you take the square root at the very end. And notice my symbol. So I've got my mean and standard deviation too. Okay, now it says we're supposed to interpret, but let's do the calculator first. So what I want you guys to do here, I'm gonna write your calculator instructions. Too fast, the brain too fast for hand. Okay, when you're ready, go ahead and do this. And don't enter this in, enter the original table. Yeah, the children in my other classes are bored or something. Okay, so I put the x's into L1, the probabilities into L2, then stat, calc, one variable stats, and I already have mine set up as L1, L2, but if you need to put L2 here, just put second two. Notice the lists are all above the numbers in whatever color your calculator does. Mine is like light blue, I guess. So second two. Anybody need assistance? Okay, and then notice it gave us the mean and the standard deviation, and that's all we're going to need for this particular problem. So the thing is, the calculator won't give you variance. So come back over here. So what you do is you say, okay, the mean is 3.9. Do you guys see where the mean came from? Notice I'm changing my symbols. Standard deviation is 1.3. And then if the problem asks you for the variance, you just do 1.3 squared, which is 1.69. So when you calculate it by hand, you get the variance first. But when you calculate it in the calculator, you have to actually do an extra step to get variance. Oh, hold on, Jackson, there you go. You got it? Okay. Okay. Over many spins, a spin will typically vary from the mean of 3.9 by 1.3. So I'm looking for this language typically vary from the mean, and I'm looking for over many spins because it's, it's not perfect every time. It's staying over a lot of. Now, really quick note here. This problem is weird because the spinner doesn't really have units. Normally, it would say something like point, or, like if it was a game, something like that, or centimeters, or something with units. Typically, there would be some kind of unit situation here. This one's weird because it's like a spinner and just getting numbers, which don't seem to have a unit. But as I'm saying, don't forget your units. Okay, last thing of the day, and we're done. Okay, last thing. So you know how I told you to leave that little line on the table, the very first table we did? What we're gonna go back and do is add them up. And I have a question, a chapter one question. What percentile is the median? This should not be a hard question. If you think it's hard, you're over the 50th. Yeah, okay. Okay. 50th percentile. Okay, so what we're gonna do is we're gonna go back to the table and find the 50th percentile by adding up the probabilities. So put cumulative X on this line. Okay, and this would just be 0.3 because it's the first one. Don't do it. And then this would be 0.5 because it's cumulative, so that means it's adding both of these together. And then this one would be 1.0 because it's adding all of those together. Okay, so what is the median? Median is at the 50th percentile. What's the median? So the median is 4 because it's at the 50th percentile. Okay, and what do I care about that? So the care is to come back over here. So we're going to flip back again. I'm so sorry. The mean was 3.9. The median was 4. Okay, what on earth does that do for me? Like, why do I care? No idea. Why would you compare the mean and median of a distribution? So, okay, what you use that for is a little baby piece of evidence to help you determine the shape. Look back at the previous graph, the histogram we made that looks like a bar graph. Isn't it really difficult to tell the shape of this thing? Okay, I think that it looks kind of left skewed. I also think it looks kind of symmetric. I also think it kind of looks uniform. Okay, now which one of those can I eliminate if the mean and median are super close to each other? That means there's no tail. So that's either symmetric or uniform. Okay. Notice I skipped the describe its shape earlier. I skipped it on purpose because I knew we were coming back to it. Did you get it? I'm sorry. Okay, that's it.